Hi, hello, namaste. Welcome back to AIMS Dare to Success YouTube channel. Today we are discussing about Senior Inter Mass 2A complex numbers. It is very important chapter for IPE as well as competitive exams. First, I can explain you concept from this chapter complex number. First of all, complex number is denoted by Z. Z is equals to x plus iy. Here x is equals to real part and y is equals to imaginary part. So in complex number, both imaginary part as well as real part are coming at a time. Suppose z is equal to x plus iy. Okay, some members will get confusion. If I get x minus iy, here conjugate of z is equals to z bar. Conjugate of z is equal to z bar, that is x plus iy conjugate value is x minus iy. For I coefficient, opposite symbol minus I. This is conjugate symbol. So conjugate of x plus iy is x minus iy. Conjugate of x minus iy is x plus iy. You can use this concept. Conjugate of x plus iy is equals to x minus iy. And next, conjugate of x minus iy is equals to x plus iy. You can remember. And one more major important one, I square is equals to minus 1. Where do you get I square is equal to minus 1 means I is equal to square coming into this side under root minus 1. Okay, so this part inside of the under root, if you get it negative symbol, that is denoted by I. In the replace of root minus 1, you can take I value. So simplify, you will get I square is equals to minus 1. According to this, my dears, z is equal to x plus iy. Point wise, if you want to write, we can take x comma y. Okay, x plus iy can be written as x comma y in point wise. Both are same in this chapter. Next, we can go z1 is equals to a plus ib. This can be written as a comma b. Next, z2 is equals to c comma d or c plus id. Adding for these two values z1 plus z2. To add these two complex numbers, you can use this concept a comma b plus c comma d. Here just real part to real part you can add it, a plus c. Imaginary to imaginary you can add it, b plus d. So to addition, real part to real part, imaginary part to imaginary part. Okay, coming to next, same concept for subtraction. z1 is equals to a comma b and Z2 is equals to C comma D. Okay, my dears, for this concept I can use Z1 minus Z2. How to subtract Z1 minus Z2 means real part to real part A minus C, comma imaginary part to imaginary part B minus D. Addition completed, subtraction completed. Next Z1 is equals to A comma B. Next Z2 is equals to C comma D. For these two complex numbers, if you want to equate Z1 is equals to Z2, how is it possible, my dears? Here real part to real part equating A is equal to C, imaginary part to imaginary part equating B is equals to D. This is subtraction, addition as well as equating of two complex numbers. Okay, now we want to go to, suppose if Z is equals to, if Z is equal to A plus IB, then Z bar, okay, Z bar is equals to A plus IB bar. Bar means conjugate A minus IB. Suppose if Z is equals to A minus IB, okay, then Z bar is equals to A minus IB bar. So this is equals to opposite symbol of I plus will come. So A plus IB. Next here additive inverse. Next concept is additive inverse of Z is equal to A plus IB is, additive inverse means complete this complex number multiply by minus, that is minus A minus IB. This is the additive inverse of A plus IB. Suppose next if you have additive inverse of Z is equals to A minus IB is, here also multiplying with minus to each and every value, that is minus A opposite symbol plus IB. Like this you can continue. According to the given complex number, you can multiply by minus for every real part as well as imaginary part. Next additive inverse completed, my dears. Then next multiplicative inverse of Z is equals to A comma B. I am writing A comma B or A plus IB, both are same, there is no changes. A comma B is equal to here A divided by A square plus B square. Next comma, here B you can take opposite symbol minus B divided by A square plus B square. Multiplicative inverse of Z is equal to A plus IB or A comma B, just A by A square plus B square, comma opposite symbol of this part minus B by A square plus B square. If you can get confusion, don't confuse, here minus B I to you can take it opposite symbol plus B, that is a difference. Okay, my dears, so multiplicative inverse completed. Then next concept is Z1 into Z2 multiplication concept. If Z1 is equals to A comma B, okay, Z2 is equals to C comma D, then Z1 into Z2 is equals to, here real part to real part multiply AC, then minus imaginary part to imaginary part multiplication AC minus BD. Next, first last multiplication AD, then keep place middle values multiplication BC. When you are having two complex numbers, Z1 is A comma B, Z2 is C comma D. If you want to multiply those two complex numbers, Z1 into Z2 is equal to real part multiplication AC, then write minus imaginary part to imaginary part multiplication, comma first last A into D multiplication, then keep plus middle two values BC multiplication. Very easy. Next, if Z1 is equals to A comma B, Z2 is equals to C comma D, then next division of two complex numbers, Z1 by Z2. Okay, Z1 by Z2, that is, I can write like this, A plus IB divided by C plus ID. A comma B, A plus IB, C comma D, C plus ID. If you have like this, you can use division of this concept. Here real part to real part multiplication, then keep place imaginary part to imaginary part multiplication divided by denominator values ki square, that is C square plus D square, then keep comma. Now cross multiply, first you can do like this BC, then keep minus, these two terms you can multiply AD divided by denominator values ki square and addition C square plus D square. This is a division of two complex numbers. So one more time, real part to real part multiply plus imaginary part to imaginary part multiply, then addition AC plus BD divided by C square plus D square. Next, like this, BC minus AD by C square plus D square. This is multiplication of division of two complex numbers. Now we are moving to next concept, that is square root of A plus IB is equal to, you can take a plus or minus symbol and take one big root. So mali no root A square plus B square. Okay, mali here coming to this plus I, you can write and take one more big root and numerator again root A square plus B square. Here numerator plus A, here numerator minus A, next divided by, here also next divided by, here 2 and 2. Okay, both are same, just left side real part plus A, in imaginary part minus A, here plus I. This formula is very easy and important for concept. Square root of A plus IB is equal to plus or minus big bracket start, big root numerator root A square plus B square plus A by 2 plus I into root, only again root A square plus B square minus A by 2. This is square root of A plus IB concept. And one more thing, my dears, modulus of a complex number. you want to find modulus of a complex number, if z is equals to a plus ib or a comma b, then mod z, modulus means mod z is equals to mod a plus ib. Mod a plus ib concept is under root a square plus b square. Same part here we used. Okay, that is related to modulus of a complex number. Next, we will enter into polar form. Polar form or modulus amplitude form. Polar form or modulus amplitude form. Suppose if we have z is equals to a plus ib. Okay, if you want to convert in terms of modulus amplitude form, we can write polar form, then polar form or modulus amplitude form is equal to r into cos theta plus I sin theta. This is polar form or modulus amplitude form. Here, what is r value? Root over a square plus b square, that is modulus of given complex number. And next, cos theta is equals to a divided by root a square plus b square. Next, sin theta is equals to b by root over a square plus b square. Okay, by using this concept you can continue. Okay, my dears. Next, argand of complex numbers multiplication z1 into z2 is equal to argand of z1 plus argand of z2. From 10th class, logarithm concept look like log ab is equals to log a plus log b vastadi kada. According to that concept, it is look like arg z1 into z2 is equal to arg z1 plus arg z2. Like this, my dears. One more, argand of z1 by z2 is equals to arg z1 minus arg z2. This is also look like from 10th class logarithm concept. Log a by b is equals to log a minus log b. Okay, so argand of z1 by z2 is equal to arg z1 minus arg z2. Like this concept we will continue from this chapter. If it is there, I can tell you more concepts from this. Maximum for complex number concept. These are the major concepts we can use. Okay, my dears, I hope you all are understanding clearly. If you not understand, you can ask me by using live chat. Suppose square concept. Square means, according to 10th class concept, all sides are equal. All sides are equal. Here, complex number concept, suppose a point 1 comma 2. I am giving you just logically, not exactly. B point 3 comma 4, C point 5 comma 6, D point 7 comma 8. They can give you like this. 1 comma 2 means generally A is equal to 1 plus 2i ఇట్లా ఇస్తాడు. నెక్స్ట్ b is equal to 3 plus 4i, c is equals to 5 plus 6i, d is equal to 7 plus 8i. Here you can use distance formula. Okay na? So distance between 2 points a b is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square. By using this concept, to get a square concept, we should take all sides are equal, that is AB is equal to BC is equal to CD is equals to DA. Later diagonals also must be equal, that is AC is equals to BD. Suppose if you have like this A, B, C, D, the distance between AB is equal to the distance between BC is equal to the distance between CD is equal to the distance between DA, must be equal. Next diagonals AC and BD also equal. Okay my dears. Next this is the concept of square. Next a rhombus. A rhombus concept, maximum sides are equal, that is AB is equal to BC is equal to CD is equals to DA. All sides are equal, but diagonals, what are the diagonals like this? AC and BD not equal. Diagonals AC not equal to BD. This is the concept of rhombus. Okay, next equilateral triangle. Equilateral triangle means we will have 3 points only. Equilateral triangle concept, all sides are equal, that is AB is equals to BC is equals to CA. This is also from the concept of distance between 2 points concept. Okay my dears. So according to this concept, totally maximum concept covered for complex numbers chapter. Okay, so next class we will discuss concept wise problems. Okay, independently concept wise problems we will discuss. సో అప్పటి వరకు ఈ క్లాస్ని విని మంచిగా నేర్చుకొని సో కాన్సెప్ట్ గుర్తుపెట్టుకోండి. నెక్స్ట్ క్లాస్లో మనం ప్రాబ్లమ్స్ స్టార్ట్ చేస్తున్నాం కాబట్టి అప్పటి వరకు ఇది మీకు మంచిగా హెల్ప్ అవుతుంది. సో ఈ వీడియో మీకు నచ్చినట్లయితే సబ్స్క్రైబ్ చేయండి, షేర్ చేయండి, లైక్ చేయండి. ఓకే, we will come together in the next class. Daily I will continue live class concept wise. మ్యాథ్స్ అంటే భయమొద్దు. నా వీడియోలు వినండి, విని గుర్తుపెట్టుకొని ప్రాక్టీస్ చేసుకోండి. భయం పోతుంది, మ్యాథ్స్ అంటే భయం పోతుంది. ఈ యూట్యూబ్ ఛానల్ ఎయిమ్స్ డైరెక్ట్ టు సక్సెస్ యూట్యూబ్ ఛానల్లో మ్యాథ్స్ 1A 1B 2A 2B ఇంటర్మీడియట్ రిలేటెడ్ అన్ని చాప్టర్ వైజ్ ప్లేలిస్టులు ఉన్నాయి. ఒక్కసారి ప్లేలిస్ట్లోకి వెళ్ళి చెక్ చేసుకొని మంచిగా ప్రాక్టీస్ చేసుకోండి. ఐ విష్ యూ ఆల్ ద వెరీ బెస్ట్. టేక్ కేర్. బాయ్ బాయ్. జై జవాన్, జై కిసాన్, జై బోలో భారత్ మాతా की जय. जय हिंद.